Good evening, everyone. So, in today's lecture, again we meet, and this is a lecture for engineering mathematics, and we are going to discuss about the Eigen values and eigenvectors. So, before starting the lecture, I'm going to discuss about an event which is organized by InnovaWorld, and you can win the prize money by participating in this event. And who can participate in this event? Any graduate or undergraduates or research scholars who are currently pursuing any degree or studies in any institution or college or universities across the globe. So any interested aerospace candidates or aspirants whose age is limited to 16 to 30 years can register to this event. For more information, you can visit the website www.innovaworld.info. And the description, all the links and other things and other details are shared in the description box, so you can check. So now we begin with our today's lecture, which is the details of eigenvalues and eigenvectors. And this particular lecture, it is very important for engineering mathematics students, not only for examination or any competitive examinations, but if your real life and in application based, this is very useful. And the use of eigenvalues and eigenvectors, okay, are widely used in applications, in engineering applications, okay, in computer science, in civil engineering, mechanical engineering, okay, almost everywhere in engineering sciences. uh, and also in image processing. Okay, so in computer science students, you can use this in image processing. In civil engineering students, by building any bridges. And in mechanical engineering students, they can use this concept. This is actually the concept of vectors and linear algebra. Okay, and let us start with it now. So we start with a picture of Mona Lisa. So you can see we have I have shown you two pictures here. The first picture, it's a real image of Mona Lisa. Real means it's a original image of Mona Lisa. And the second picture, you can see it is the curved image. That is the image is slightly, it is bent. You can see, and that is now. Let me. Now you can see there are two vectors. Okay, this is the first vector. This vector is the first vector, the blue colored vector, and red vector, you can see this is the second vector. Okay, so 2 points you can see here represented by two vectors. So this image, it is the real image, that is the original image of Mona Lisa. You can see I have here this image. It is distributed into many boxes. Okay, so you can consider here it is different pixels, and you can see two vectors I have represented, and this vector is for this point, and the second vector, the red vector, is for this particular point. Okay, and in the second image you can see this image is slightly bent. Why? Because I have operated some matrix operation on this image, that is on this vector. Okay, so there are 2 points on the vector, that is this point, the point 1, suppose this is first point x or x1, and this is the second point, this is suppose x2, represented by the blue and the red vectors. So now you can see the x1 point in the second picture, it is slightly moved. This is the x1 point, this is the position vector of the x1 point. Now it is slightly moved towards the right side, right? But x2 vector, it remains in the same position. Okay, so the direction of the x2 vector is not changed in the second figure, but the direction of the x1 vector is changed in the second figure. Okay, so eigenvector, it means that after operating some elementary, that is linear operations. Okay, linear transformation means the matrix operations. Okay, so if after operating on a matrix, that is operation on this vector, we have operated some matrix on this vector, and these two vectors has changed their position now, and the picture also you can see slightly it is bent. Now there are two vectors. One vector x2 vector doesn't change the position, the x1 vector changed its position. So eigenvector is only those vector after operating some operations, linear operations, the vectors who does not change their direction. Okay, so here you can see the blue vector, that is x2 vector, is the eigenvector, and the red vector, that is x1 vector, it is not the eigenvector, because it has changed its direction. Okay, now come to this particular picture. You can see, okay, so it is an xy plane. Okay, xy plane. Now you can see we have shown you here a vector x. Okay, this is the vector x, sorry, this is the vector x. Okay, so this particular vector, okay, this vector is the x vector. Now you can see the direction of the x vector in this direction, right? And after some elementary operations, that is after some linear transformation, that is you can see here what is the operation. This is the matrix, actually A is a matrix here. Okay, A is a matrix here. So after multiplying with this matrix A, the vector x, it is now changed into lambda into x. What is lambda? Lambda is a scalar term. Okay, so after operating this A matrix, the x vector, it is changed into lambda into xl. So lambda is a scalar multiplied with x. Okay, so you can see the vector x and the outcome vector is also x. Okay, the input vector is x, output vector is also x, multiplied with a scalar quantity lambda. What does it means? X vector does not change here. It means that the direction of the x vector doesn't change. So you can see the picture also. This is the direction of the x vector, and after the operation, this is the direction of the x vector. It is not changed. So it means that this x vector is called the eigenvector or eigenvector. Okay. So similarly, you can see if the direction doesn't change, you can see the box. Okay, there is this box, this. This particular box, each and every sides of this box is also, the ratio is also unchanged. You can see the ratio, you can see exactly the same ratio it is remaining. That is, it actually pursues the same ratio. So it means since the direction of this vector is not changing, so each and every side, the ratio of each and every side is same here. Okay, so still it is a square box. After changing the operation, this again, this is a square box, same square box. It is not changing to any rectangle or anything else. Okay, so this is called eigenvector since the direction is not changing. Now again, look at this picture. So this picture, now you can see we have transformed it. Again, we use some elementary, sorry, we have used some matrix operations, or which is also called the linear transformation. So matrix operations on this vector. So you can see the vector here. We have used here three different vectors here. First vector, it is the yellow colored vector, that is this one, and another two vectors used by the red color, that is in the x-axis on the x and y-axis direction. Okay, so these three vectors, let us suppose this is x1 vector, this vector is x2, and this vector is suppose x3. Okay, now the yellow vector, that is the x1 vector, after the operation, now we have changed, we have transformed this vector. Okay, so after the transformation, you can see the yellow vector direction is changed now. So the x1 position, it is entirely changed. X2 position not changed. X3 position, it is also not changed. Okay, so it means which vectors are eigenvectors here? X1 is an eigenvector, x3 is an eigenvector, but not x1. Sorry, x2 is an eigenvector. Is x2, sorry, is x1. So x2 is an eigenvector, x3 is also an eigenvector, but not x1, because the x1 change, as the direction of the x1 has been changed in the second figure, that is after the linear transformation. Okay, now we come to this particular equation, that is the equations which I already explained. Ax equal to lambda into x. Here in this equation, A is a matrix. Okay, A is a matrix which operates on this vector x. Okay, and lambda is actually the eigenvalue, the scalar quantity is called the eigenvalue, and this x is called the eigenvector. Okay, I already told you that is x, since the direction is not changing, so the input vector is also x, the output vector, again we are getting the same vector in return. There is a x vector is not changing, only the x vector is multiplied with a scalar quantity which is the lambda, and which is called the eigenvalue. Okay, so now we will there are too many means applications are there from these eigenvalues and eigenvector, and in any competitive examinations or in your semester exams also, you will be getting many questions from this particular topic, eigenvalues and eigenvector. So let us start with the example, very simple example now. And the example, it is showing the matrix A 2 3 2 1, and we need to find the eigenvalue of this matrix. Okay, first I will let you know how to find out the eigenvalues, and then I will discuss about the eigenvectors, how to find out the eigenvectors. So let us start with this matrix. Okay, so I already explained eigenvector is actually always follows the relation Ax is equal to lambda x. Okay, so what does it mean? It means that Ax equal to lambda x, it means that here A is a matrix, x is the eigenvector, lambda is the eigenvalue. Okay, now if I just use the equation like this: ax minus lambda x is equal to 0. Okay, 0 means it's a vector 0. Okay, now I can write this equation like this. Okay, how can I write this equation? Because you can see here, since it is a vector, x is a vector, a is a matrix. Okay, so since we are operating this all these things, that is, we are operating on the matrix and we are operating on the vectors, and only lambda is the scalar quantity, so x can be taken outside, but lambda cannot be left alone because we are actually working on the matrix. So it will be lambda into I. What is I? I is the identity matrix. Identity matrix here. Okay, so actually this is the relation, okay, by using which we can find the value of lambda. Okay, so we will be using this particular relation to find out the value of lambda, that is the values of the eigenvalues, okay, from this particular matrix. Okay, so let us suppose that is x is the eigenvector. So x is eigenvector. Let us suppose x equal to, since this is a 2 cross 2 matrix. Okay, so let us suppose x equal to x1, x2. This is the vector. This is the eigenvector, suppose. Okay, so we will use ax is equal to lambda x here. Now it means that 2, 3, 2, 1, x is x1, x2 is equal to lambda into x1, x2. Okay, so this particular thing, that is, now we can get the same thing, that is, now we use this equation, because ax equal to lambda x, after ax equal to lambda x, and from this equation we are getting this particular, the last equation. So it means we can write here, that is 2a minus this. Okay, so we can write a minus lambda into I whole x equal to 0. So I use this equation directly now. So a means 2, 3, 2, sorry, 2, 1. Okay, this is a matrix, minus lambda into I means 1, 0, 0, 1. This is the identity matrix. Okay, x means x1, x2 is equal to the 0. Okay, 0 vector. Okay, so now actually by using, so this particular equation we can write. Now how can I find lambda? Actually lambda can be found, now if I take the determinant of this particular, sorry, this a minus lambda I. Okay, if I take the determinant of this particular matrix, a minus lambda I matrix, and we equate this to 0. Now after taking the determinant, this matrix value, it will be, actually this was, firstly it was a matrix, a minus lambda is a matrix, but after taking the determinant value, it will be converted to a scalar value. And now the right hand side, previously it was a vector, now it becomes a scalar. Now this 0 is a scalar quantity. Okay, so eigen values can be found by using this particular determinant, that is determinant of a minus lambda I is equal to 0. Okay, and this particular equation is called the characteristic equation. this particular equation is called the characteristic equation. And after solving this characteristic equation, the values of lambda, whatever we get, are called the Eigen values. Okay, so let us start with this example right now. Okay, so I erase all these particular parts, previous parts. I'm directly using the characteristic equation to find the eigenvalue. So whenever a problem is given in the exam, or you'll be facing this kind of problem, directly you can use the characteristic equation to find the eigenvalue of the matrix. Okay, so what is our characteristic equation? This is determinant of a minus lambda I is equal to 0. Okay, so it means determinant of 2 3 2 1 minus lambda into 1 0 0 1 is equal to 0. Okay, now this particular determinant, it can be written in this form. Okay, if you just evaluate it and simplify this determinant, we can get like this: 2 minus lambda 3 to 1 minus lambda is equal to 0. You can simplify this determinant, you will get exactly this equation, this particular equation. Okay, so in short, if this A matrix is given, directly you can write this last determinant, that is the diagonal elements 2 and 1. Okay, you can just subtract lambda from the diagonal element, that is 2 minus lambda and 1 minus lambda, and take the determinant of this matrix and put it equal to 0 and solve it. So directly, without using this and this, you can directly use this equation. Just remember, the diagonal elements is subtracted by lambda and take determinant equal to 0. Now solve this equation. Now I am going to solve this. So determinant, it is, if I break the determinant, I am having 2 minus lambda into 1 minus lambda minus 6. 3 into 2, 6 is equal to 0. Okay, so again solving this, we are getting 2 minus lambda, 1 minus lambda, so it becomes 2. Okay, and it is minus 2 lambda, it is minus lambda minus, plus lambda squared minus 6, which is equal to 0. Now you need to solve this equation and need to find the value of lambda. This is a quadratic equation. You can easily solve this quadratic equation by using the Sridharacharya formula or by factorization. Okay, so let us simplify this equation again. So it is lambda squared, okay, and it is minus 3 lambda, and it is minus 4 is equal to 0. So now we have to solve this equation and find the value of lambda. So let us find the value of lambda now. Let me erase this part. Okay, now this part has been erased. Now I am going to solve the equation in the right side. So let me take the pen again. Yeah. So now lambda, let us directly use the Sridharacharya formula, okay, to evaluate this equation and to find the value of lambda. So lambda value, it can be used by minus b, that is 3, plus minus root over of b square, that is 9, Okay, minus 4ac, that is it becomes plus because it is minus 4. So 16 divided by 2a, it means only 2 because a value is 1 here. Okay, I hope that you all know this particular formula, so the Acharya formula to evaluate any quadratic equation. So we have now two values. One is 3, so plus minus, it is 16 plus 9, it is 25. 25 root means it is 5 by 2. Okay, so now we are having now two values. One is 3 plus 5 divided by 2. 3 plus 5 is 8 divided by 2 means 4. And another one is 3 minus 5 means minus 1. So 4 and minus 1, these two are the eigenvalues for the matrix A. Okay, so what are the eigenvalues? 4 and minus 1 are the two eigenvalues for this particular matrix. Okay, remember one thing, since the matrix is 2 cross 2 matrix, so maximum we can get two eigenvalues, not more than that. Okay, second thing is, our eigenvalues sometimes equal eigenvalues can we get? Yes, we can also get equal eigenvalues. Okay, let us suppose there are 4 and minus 1 we are getting. In some matrix we can also get 1 comma 1 or 2 comma 2 like this. Okay, so but you can see eigenvalues, we can get two eigenvalues, but the two values are maybe two values may be same. Okay, maybe different, maybe same also, but the number of eigenvalues cannot cross, that is cannot exceed the uh, dimension of the matrix. There is 2 cross 2 means maximum two eigenvalues we can get, not more than that. Okay, so let us give you let us explain another example of eigenvector, and this time we will be getting a 3 cross 3 matrix. Okay, so another example of 3 cross 3 matrix. Okay, so let us now consider a matrix A, and which is equals to 4 6 10 3 10 13 minus 2 minus 6 minus 8. Okay, so this is the uh, matrix A matrix. Now we need to find out the eigenvalues of this matrix first. Okay, okay, so how can we find the eigenvalues? So here you can see the previous matrix, you can see the previous matrix. Okay, the previous matrix is a 2 cross 2 matrix. So for 2 cross 2 matrix we got a quadratic equation, okay, with lambda. But since this is a 3 cross 3 matrix, so obviously we will be getting a cubic equation in this case. Okay, I need to solve the cubic equation here. So let me first discuss about the characteristic equation. Since without characteristic equation we can't find the value of lambda. So what is the characteristic equation? Sorry. So A minus determinant of characteristic equation is determinant of A minus lambda I is equal to 0, right? So A minus lambda I, it means I already told you, directly we can write the matrix that is a determinant like this. Sorry, but directly we can write the determinant like this. Determinant of, so the first diagonal element is 4. Okay, so this is first diagonal element, it is 4, so we can write 4 minus lambda, 6, 10. Okay, the second diagonal element is 10, so what we can write, 3, 10 minus lambda, 13. Third diagonal element is minus 8, so what we can write, minus 2, minus 6, minus 8, minus lambda. This is equal to 0. So directly we can write this particular equation. Okay, now we have to break this determinant according to the determinant formula, and we can have the values of lambda, then solve it, and then we can have the values of lambda. Okay, so how to do this? So let us break the determinant first. If I break the determinant, so it is 4 minus lambda, and 10 minus lambda into minus 8 minus lambda minus minus 6 is the first one. Second one is minus 6 into 3 into, okay, this one, these two will be multiplied, and then now it is minus minus, so becomes plus 26, 13 into 2, okay, and plus 10 into 3 into 6, so minus, it will be 3 into 6, and minus of, so minus and minus 2, it will be plus 2 into 10 minus lambda. Okay, so this will become the means the is equal to 0. So this becomes the characteristic equation. Now we have to means simplify this equation, and we'll be getting the value of lambda. Okay, now there are many, we can actually use a factorization method, okay, to solve this one. Now ultimately I'm directly writing the values. Okay, so the ultimately after simplification of this particular equation, okay, what we will be having, we will be having 4 minus lambda, 4 minus lambda into minus 2 lambda plus lambda square. Okay, so this is the final equation. Okay, after the simplification of this, this will be a cubic equation actually. Okay, so after having this, we are getting this one. Okay, if you don't know how to solve a cubic equation, okay, let me explain a little bit, let me give you the explanation of a little bit of that one also, and it will be easier for you. Look, after means simplification, we will be getting an cubic equation like this. Okay, the cubic equation, it will be like this: minus lambda cube plus 6 lambda square minus 6 lambda minus 8 is equal to 0. So you'll be getting this kind of cubic equation. Okay, we can write this equation like this: it is lambda cube, okay, minus 6 lambda square minus, sorry, plus 6 lambda plus 8 is equal to 0. So first we need to take a factor, means we need to use the factorization method to find out the values of lambda here. Okay, so what is our first step? Okay, there is a very simple process to find out what is the first factor. If I want to factorize this equation, we need to find the value of lambda. Okay, we need to find a value of lambda by trial and error method. So trial and error means First you need to put lambda equal to 0, then lambda equal to 1, then you can put lambda equal to -1 or +2 or -2. Okay, so you need to use a trial and error method here. Okay, and you need to choose a value of lambda in such a way that this will become, this particular expression becomes 0. Okay, so can you tell me what is the value of lambda by which we can say that this particular things will become 0? Okay, if I put lambda equal to 4 in this case, will it become 0? Okay, so I'm giving you some time just to check. Okay, or you can choose the value of lambda. Okay, and tell me in the chat box that for which value of lambda this particular expression becomes 0. Okay, okay, so let me tell you, if we put lambda equal to 4, then this particular equation becomes 0. You just put lambda equal to 4 here, 4 cube, so 4 cube means it is 64. Okay, minus 6 into 4 square plus 6 into 4 plus 8. Just put lambda equal to 4 here and calculate, you'll be getting it 0. Okay, it means lambda equal to 4 is a solution. So lambda equal to 4 is actually a solution of this particular equation. If lambda equal to 4 is a solution, we can say that lambda minus 4 is a factor. Okay, lambda minus 4 is a factor. Okay, so lambda minus 4 is a factor. Similarly, one thing I need to just, it's a note I'm giving you. Let us suppose lambda equal to minus 4 is a solution, then what will be the factor? Then the factor will be lambda plus 4 will be the factor. Okay, lambda equal to 4 means lambda minus 4 is a factor, one of the factors, and lambda equal to minus 4 if it happens. Okay, in this case minus 4 is not the solution, but if lambda equal to minus 4 is the solution, then lambda plus 4 will be the factor in that case. Okay, so these particular things we do not need right now. Okay, now how can you solve it? Okay, the solution will be like this. Since lambda minus 4 is a factor, okay, so we will be writing lambda minus 4, the factor, since it is cubic equation. So we'll be writing lambda minus 4, lambda minus 4, lambda minus 4, three factors like this, exactly like this. Okay, in between we will just leave one step empty. Okay, to balance the equation. Okay, now in the third step, the second step will be empty. Just write in the third step three factors, lambda minus 4, lambda minus 4, and lambda minus 4, in between a gap. Just make some gaps. Now balance the first and third equation. Now balance it. What is the first term? Lambda cube. So I am going to multiply lambda square so that it becomes lambda cube, right? Now after multiplying with lambda square, okay, the result I will be writing in the second step. It becomes lambda cube, okay, minus 4 lambda square. Okay, now again go to the first step. What is here? Minus 6 lambda square. Now the second step is minus 4 lambda square. So how can I get minus 6 lambda square? If I do this, minus 2 lambda square. Okay. So now again I need to balance this part with the third equation. So if I do this, minus 2 lambda, so I'll be getting minus 2 into lambda square here. But the next step it will be plus minus minus plus 2 into 4, it means 8 lambda, right? 8 lambda. Okay, so now here what is this? This is only lambda. This is only lambda. So what we can do? So we can do it is plus 8. So plus 8 lambda. Now it is minus 0. Okay, so you can see now. Now can I get this particular equation? Okay, I think there is some mistake there. It is 30. It cannot be 32 lambda. Sorry, this one mistake is there. Okay, so it is 8 lambda. You can see. So 8 lambda means we have multiplied. It is minus 2 lambda. It means minus 2 lambda square. So I have multiplied 2 into lambda. It becomes minus 2 lambda square. Now it becomes minus minus plus. So 4 into 2, it is 8 lambda. Okay, but what is here? It is 6 lambda. It is 6 lambda, right? So how can I get 6 lambda? So if I put here 6 minus, there are some mistakes. It's not working. Okay, just wait for a minute. There is a technical problem issue. It's working now. Yes, it's working now. Okay. Sorry for the interruption. It's actually not working. Okay. So sorry for the interruption. There is a technical issue which it's not working. So okay. So let us uh, use it again. So it's a cubic equation. What I have told you. Okay. So x equal to 4 is a solution. So it becomes like this, x minus 4. It becomes a means a factor here. So lambda minus 4, sorry, lambda minus 4, lambda minus 4, and lambda minus 4. Okay, so it becomes a factor. So lambda minus 4, now the first is lambda square. So lambda square, it is lambda cube, okay, minus 4 lambda square. Okay, now what we are getting, it is 6 lambda square, so it means that minus 2 lambda square. Okay, so we are getting 6 lambda square here. 4 plus 2, it is 6, yes. So it is minus 2 lambda. So minus 2 lambda means minus 2 lambda square. Now minus minus plus. Okay, uh, 8 lambda. Okay, so it becomes 6 lambda. It's 8 lambda, it is 6 lambda. So 6 lambda means it is minus uh, 14 lambda. If I, sorry, doing something wrong. 2 lambda. So minus 2 lambda. Okay, so minus 2 lambda means 8 minus 2, it is 6 lambda. We will be getting 6 lambda, 8 minus 2. And again, to balance this 2 lambda, it is minus 2 I am multiplying here. So it becomes minus minus plus 8 equal to 0, equal to 0. Okay, I am explaining it a little bit first because due to some technical glitch, it is system was not working before some time. Okay, so if you are having any doubt with this particular calculation, okay, actually these are means everybody, I think, you know how to solve a cubic equation by using this factorization method. Okay, if anybody has any doubt, you can just comment in the comment box. Okay, I will be giving you another lecture for this, that is how to solve this particular equations, quadratic or cubic. Okay, if you are having any kind of problem with solving with the equation solving techniques. Okay, okay, so now in the last problem, so I am getting lambda minus 4. Okay, lambda minus 4, it's common. So now if I take lambda minus 4 as a common, so it becomes lambda square minus 2 lambda, okay, minus 2. Now look at this, we are getting factored. Two factors here. First factor is lambda minus 4, second factor is lambda square minus 2 lambda minus 2. Okay, so now first factor is lambda minus 4, so already we know that lambda equal to 4 is a solution. Okay, now we need to solve this equation, lambda square minus 2 lambda minus 2, to find out the value, another two values of lambda. Okay, and which will be giving you another two values of lambda. Just again use the same equation. Okay, so again use the same equations. What are the equations? The equation is Sridharacharya formula, that is lambda equal to minus b. Here it is 2 plus minus root over of b square minus 4ac. So b square means 4. Okay, a into c means it is again 8 plus 8. Okay, so 2 plus minus, okay, square root of b square means 4 minus 4ac, yes, divided by 2a, so 2. Okay, so what are the values we are getting? So here we are getting 2 plus minus, it is 12 by 2. Okay, so it is actually 2 root 3. Okay, so it means 2 plus root over of 12, it means 2 root 3 by 2. So plus minus, so what are the three values we are getting, lambda values? First lambda value is 4, second lambda value is 2 plus 2 root 3 by 2, third lambda value is 2 minus 2 root 3 by 2. So these three values are eigenvalues here. Okay, so now uh, These are the techniques to find out the eigen values. Okay, now how to find out the eigen vectors? Okay, so eigen vectors, it can be found by using this particular equation, that is ax equal to lambda x, this equation. Okay, so to find out the eigen vectors, we first need to find out the eigen value, and for each and every eigen value we will be having separate eigen vectors. So it means that if a matrix is given, suppose this is a 2 cross 2 matrix, and we are having two different eigen values, so it means how many eigen vectors we will be having? We will be having two different eigen vectors for that. Okay, so one equation of a 2 cross 2 system. Okay, I will give you a solution for eigen vector. Okay, also we need the concept of system of linear equations here, homogeneous equations. Okay, so let us use a matrix 0 minus 2 3 4. So the matrix is 0 minus 2 3 4. Okay, we need to find the eigen vectors. Okay, first we need to find the eigen values, because I already told you, to find the eigen vector we need to find the eigen value first. So how to find out the eigen value? We need to use the characteristic equation. So you can see the characteristic equation, it will be 0 minus lambda, because the first diagonal element is 0, then it is minus 2, then it is 3, and the last equation it is 4. So 4 minus lambda is equal to 0. Okay, let us solve this. So it is minus lambda, 4 minus lambda, okay, minus 1 lambda and minus, it becomes plus 6 is equal to 0. Okay, so this is the characteristic equation here. So we need to solve the characteristic equation to find out the value of lambda. So what are the values of lambda we'll be getting here? So after solving this, actually it becomes lambda into lambda minus 4 after evaluating is equal to 0, from where we are getting lambda equal to 0 and lambda equal to 4. So these two are the eigen values. Okay, so the eigen values already you know how to solve the eigen values. Just solve this determinant, and whatever the solution we will be getting, that will be the eigen value. Now let us find the eigenvector. How can I find it? Ax equal to lambda x. Use this equation to find the eigenvectors. Okay, now how many eigenvalues we are getting here? Two eigenvalues, lambda equal to 0 and lambda equal to 4. So for these two eigenvalues we will be getting two different eigenvectors here. Okay, so let us find out what is the eigenvector corresponding to lambda equal to 4. So eigenvector vector for lambda equal to 4. Okay, so it means ax is equal to 4 into x. Okay, let us suppose, since it is a 2 cross 2 matrix, let us suppose x equal to x1 x2 is the eigenvector. Okay, so now we put the values. A is 0 minus 2 3 4, x is x1 x2 to 4 into x1 x2. Okay, now I need to multiply this equation, these two matrices. So if I multiply these two matrices, what we will getting? It is 0 into x1 minus 2 into x2, right? So it means 0 into x1 minus 2 into x2, and 3 into x1 plus 4 into x2. Okay, this will be equal to 4x1 4x2. right? So again, we have to return to the system of linear equations. You can get here how many equations we are getting. A system of linear equations here. The first equation, it is, you can see, it is 0 into x1 minus 2 into x2 and 4x1, so it becomes 0 into x1, okay, minus 2x2 is equal to 4x1, okay. And the second equation, 3x1 plus 4x2 is equal to 4x2. Can I write this one? So the first equation, this becomes the first equation. It is obviously equal to the first, this value, and the second equation, it is obviously equal to this value, 4 into x2. So we are getting two equations. This is the first and second. Again, we simplify this equation. After simplifying, what we are getting, minus 4x1, 0 into x1 is 0, so minus 4x1, okay, minus 2x2 is equal to 0. So which actually means plus 4x1 and plus 4x2 equal to 0. And from this equation, what we are getting, 3x1, sorry, okay, 3x1, so it is 0 minus 2, 3x1, yes, plus, okay, now it is 4x2 and 4x2, both will be nullified at both sides, okay. So 0 into, actually 0 into x2 is equal to 0. So we are getting a system of linear equations here, okay. We are getting a system of linear equations here. So you can see here, now system of linear equations, and it is 0x1, 0x1 is 0, 4x1, 4x1 is here, it is minus 4x1, and minus 2x2 equal to 0. So both we are taking the minus sign as common. Since the right hand side is 0, so minus sign will be nullified. So we are getting 4x1 plus 2x2 is equal to 0. This is equation number 1. And from the second equation, 3x1 plus 4x2 equal to 4x2. So 4x2 and 4x2, if I take 4x2 on the left hand side, they will be nullified. So simply it is 3x1 equal to 0, or 3x1 plus 0 into x2 equal to 0. This is the equation 2, okay. So how many values we are getting now? Okay, so simply equation 1, 4x1 plus 2x2, we can write this equation as 2x1 plus x2 equal to 0. And from the second equation, we can get x1 is equal to 0, because if I solve this, it is x2 value is totally 0. It is 3x1 equal to 0, it means x1 equal to 0, okay. So if I put x1 equal to 0 in equation number 1, we are getting x2 equal to also 0. So here 0 0, it becomes a Eigen vector corresponding to lambda equal to 4. Okay, similarly we can get another eigenvalue for lambda equal to eigenvector for lambda equal to 0. Okay, so I'll be explaining some other examples of the eigenvectors, how to find out the eigenvectors for another 2 cross 2 matrix also, and also for 3 cross 3 matrix in the next lecture. Okay, thank you everyone for being with us.